have a question about with regard to the valence, positive, negative. A lot of people doing ratings, like for recommendation of movies or apps or whatever, have stopped paying attention to things like 5-star scales, or they've dropped, like YouTube dropped down to just likes or dislikes. And they say that's because if you look at the distribution of people's ratings, it's pretty much all
5 and 1.
one side or the other. And in fact, there's hardly anything on the negative side, a lot of people say. So it's really just likes that you have to pay attention to, which may be why Facebook is just concentrating on that, and a lot of other people are just looking at likes. But did you see that in the numbers for sentiment analysis, or are they pretty well distributed on the two ends?
It's very evenly distributed by the algorithm we're using, but we're not using a ground truth algorithm. We're not using actual ratings. We're basically using words and their content.
There's a lot of negative stuff as well as positive?
Typically, yes, especially on the web. A lot of stuff, people are complaining about the products and saying very negative things. I wouldn't say there's any lack of negative comments, but it's not the same kind of thing you're talking about where you're rating a book or you're rating a movie. It's, you're complaining about stuff. People complain on the web all the time. Yes?
Well, what about a word that has equal and opposite meanings? Like, for example, I might review an iPod and say, the iPod is a cool device, but I am very cool towards AT&T, for example. The word cool, then, is bad in one context, good in the other context. Or another example, I might say that something is awfully pretty, and then the next time I say it's pretty awful. And now, unless you're a context-sensitive machine, you're going to be easily thrown by the vagaries of human language use. Do you take much account of that?
I'll say this about that. I mean, a couple of things. One is, it differs by domain, and I'll give you an example that one of the earliest ones we found in the healthcare domain. The very word care, normally that's a positive word. In the healthcare domain, it's not positive at all. It's just a neutral word. It's just the word you use to describe the domain. So we realized, first of all, we had to give a transparency to the user about the dictionary itself. And so the users can go in and, first of all, they can see what's causing the rating. I don't know if I have a slide about this, but no, maybe not. But it actually shows you, when you click through here, the snippets themselves, and the individual words are highlighted green and red as far as which are positive and which are negative. So you can quickly, as a domain expert, realize, oh, that word care, I need to take that out of my positive dictionary because it's going to mess me up. The second thing is, what you're saying is still going to be true, or awfully. And I don't know of a really good way to fix that. I'm not going to try. What I'm going to do is say, you need to look for significant relationships between negative affinity and your brand. And if you have enough data, it's probably going to be right, even if I missed the pretty awful one. And then finally, when you get all done, and all said and done, you need to do the confirmation. This is just a hypothesis at this point. The confirmation is when you click on this box and look at the 6 examples and see what they're saying. And if they're saying pretty awful when you thought they meant awful, or thought they meant good, or whatever, then, the human is the ultimate judge of this. The next analytic is this idea of key influencer. Who are the people who are doing the talking, and who are the people who are being pointed to by the people doing the talking? And those are the 2 things most our customers want to know about. The sort of people who are generating the content and people who are looked up to by those generating the content. So we can do this at several different levels. You can do it at the site level, like this one is showing. You can do it at the page level, or you can do it somewhere in between, which is like the author of the blog or the poster of the message board. Finally, there's this, what we call the alerts tab. And this is really the tab that Mars most wanted. And it's kind of think of it as like a table of contents to the blog space. Basically, it's taking all the concepts you thought were important, starting with the company and its brands, going down through the key concepts, looking at it through the hot words, and then finally the different sources. And by looking at it from this point, you can say, ooh, there's a big number here, something going on. Oh, another big number there. Or this is really something lost. I got to find out about that because that's really important to my vice president. He's really concerned about that. So, you know, you have a way to, in one table, kind of see everything that's happening. And without reading blog after blog after blog, in just a few minutes, you get a sense of the whole space of your brands and the social media space together. But here, I think it's a sentiment one. I don't know if you can see the highlighting though. Well, it doesn't look like it has highlighting. It does give you a sentiment score that you can sort by, so you can bring to the top the positive or the negative or the neutral by sorting. So here we basically have ability to click through and see the actual snippet in context, the words that were used to identify the snippet. There's usually one hot word and one brand, and then the URL that takes you back to the individual thing. So where are we going from here? First of all, what we've noticed is there are certain processes that customers typically want to do with their data. And it's not always the same process for every customer. And what we wind up doing is kind of doing a lot of programming and redevelopment for every new customer we come to. So we wanted to come up with potentially what we call recipes, which are analytics that can be customized and then reused in different contexts. And the recipes can be changed subtly to allow you to do different kinds of analytics for different situations.
Work to trick to do a kind of that kind of analysis for the web. Somebody want to do something, we really post it.
We don't use that kind of search engine in our work. What you're talking about is really a search engine sorting algorithm or a ranking algorithm, like what Google uses. Basically, it's going to put certain things on top. The search engine we use, we basically get all the results. We don't rank them, we just get them all. And then whatever ranking we do is through the analytic processes, like the proximal search one that I mentioned earlier, where you're submitting many different queries and bringing to the top the ones that are the best. Or use a value calculation like you did with the patents and bring to the top the patents which are considered most valuable because of the buzzwords they use. So we're not relying on someone else's ranking algorithm to provide the results.
But it is possible that the competitor may be putting some false information, spreading our rumors or certain things.
Well, certainly on the web you will see a lot of spam data. You will see a lot of data that's really meant to fool search engines. It's what it's there for, and to get other people drawn to that site. So we have what's called junk filters in our software. What it will look for is English as a spoken language has certain statistical properties. Certain words like and the and but will occur at a certain level of frequency. And typically these spam filters won't have that regular property. It won't follow those statistics. It's usually not too hard to spot the stuff that's junk and throw that out. So we have junk filters we filter. Goal-directed analytics. The idea here is people often don't know what process they want to use, but they almost always know what they're trying to get to in the end. They know the end state they want. So we can potentially develop kind of a backward chain reasoning for analytics, which would say, okay, that's the goal you want. Here's the things I know how to do to take data and get you to that result. Let's just go ahead and do one of those things and create a process to go from your data to that result. It might not be the right result at first, because the choices I make along the way in that process may be the wrong choices for you, but at least I'll sort of show you a potential process to use, and you can go back then and edit that process to create what you really want. Exploratory analytics on the index. I think proximal search is one example of this, but I think it's potentially an unmined area, a really interesting area for doing more and more kinds of analytics. Instead of working with the data directly, use the index as a stand-in for the data, you get a lot more efficiency that way. Hadoop is something that's very interesting to us, but of course, the hang-up here, the reason it's not easy is because Hadoop isn't always that interactive. It tends to be a batch processing kind of infrastructure. And we, as I've shown, exploratory analytics is very interactive. So we're going to have to find ways to interact more directly with Hadoop clusters. Modeling. More and more, customers don't just want to explore. They want to explore towards a particular purpose. And that purpose usually is some kind of prediction of the future. And if you're going to predict the future, you really have to be able to do modeling. And so, whereas before we've kind of been satisfied, or customers have been satisfied with just kind of seeing the results you saw in Cobra, where these are the different things that people are saying about your product. Now they want to know, well, how's that going to affect my sales next month? How's that going to affect my profits? So that's going to require taking other kinds of data, folding in with the text, coming up with models that kind of do more prediction. Most of what I talked about today is about the unstructured side, but with some structure mixed in. I would like to kind of take more of these techniques and apply it more and more to structured data. And again, that's partly about the modeling as well. Most modeling requires more structured data, so I think that's a general trend.